Is red meat actually bad for my gut, or is that just another health myth? Well, today we're going to dive into this hotly debated topic: vegan versus carnivores, red meat versus plant based protein, raw versus cooked. What does the gut actually prefer? Does it even have a preference? Well, joining me today is Dr. Mindy Patterson, a gut health expert and a nutritional researcher who breaks down what's really happening inside the body when you eat these different types of proteins and fibers. Okay, let's get started. Welcome to Science Genies.
Well, thank you so much for having me. So, I actually have 3 degrees in nutrition. I fell in love with nutrition. I'm also a registered dietitian. When I first went to undergraduate university at Texas A&M, and I remember sitting in my first nutrition classroom. I didn't even think it was a degree or you could do anything with it. And the professor started talking about how important nutrition is for overall health and talked about gut health and fiber. And I think that is the class that really got me hooked on nutrition. So, went on through to get my PhD, and I'm now an associate professor at Texas Women's University in Houston, Texas. But my research, I've always been interested in gut health. I think that first class, I remember he started talking about fiber. And so, what I do as a college student, I go to the grocery store and I buy Fiber One cereal. And if you don't know about Fiber One cereal, it has, I don't know how many grams of fiber, but more than 50% of your recommendation or recommended allowances in one serving. So I probably had 2 servings, right? So I ate the cereal, and of course I felt horrible, bloated, gas. I mean, it was just awful, like horrible distress. But I learned that lesson. And since then, I've thought, you know what? The gut is very powerful. And that's what I want to research when I get into the university system. So I had the opportunity during my dissertation to work on a prebiotic fiber called resistant starch and did a human feeding trial where we incorporated this resistant starch into a muffin, and we looked at different outcomes like glucose, insulin, some of the satiety hormones. And that was just the beginning of when the gut microbiome sort of came into the picture. And so I've just always been very intrigued with the gut and how fiber and diet and the microbiome all influence our overall health. And that led me to start a small company. I do have a supplement that has resistant starch in it and another ingredient that helps modulate blood glucose and help regulate it. I just love nutrition. It's ever evolving and everybody has their own story. And I just look forward to continuing my career path and helping others feel their best with diet and supplements.
Can you start by explaining what this resistant starch is?
Resistant starch is just that it resists the digestion in our small intestine. So basically, the enzymes that would normally digest starch aren't able to access resistant starch. They're not able to either penetrate the granule. So, starch is actually housed in a granule. So, there's maybe a hole or a husk or something that's very strong that the enzymes can't penetrate to get into the starch. Sometimes it's the configuration of the starch granules that prevent the enzymes from allowing access. But bottom line, because it's not digested in our small intestine, it doesn't contribute to blood sugar. So that's kind of the first step. I always say resistant starch works through your entire intestine, and it does. So that's where it helps with blood sugar, blood glucose, blood sugar, I'll refer to. Um, in the small intestine. But what happens is it enters the large intestine and it's intact. But the gut microbes love to ferment, certain ones do, love to ferment resistant starch. And that means they're just eating it, basically. So when they eat resistant starch or break it down, they produce these metabolites that also confer health benefit that aid in additional blood sugar control and help with digestive health by maintaining the beneficial gut microbes in the gut.
So, what's an example of one of these resistant starches that we would probably eat in our diet right now?
Right. So there's actually 5 types, and we get 4 in our diet. So the first, we have resistant starch 1, which is found in nuts and some of our seeds and cereals. Resistant starch 2 is found in raw, or I say raw, just ripe or green herb bananas, as well as our raw potatoes. And then our resistant starch 3 is found in those foods that are cooked and then chilled. So, like a potato salad. We also get forms of 2 and 3 in things like beans and legumes and peas, as well as corn tortillas are usually a rich source. Corn flakes, of all things, are a rich source. So, we really get resistant starch in a lot of those plant based foods that are already naturally high in fiber.
So, resistant starch too was a bit interesting because you said it was raw bananas and raw potatoes. I don't know anyone who's
Right.
eating that. So, how do we get that without eating those?
Well, you actually, even when I say raw, that has the higher amount. But when you cook that potato, it still retains the resistant starch too. It's just, however, when you chill it, it becomes resistant starch 3. I know it's a little weird concept, but we still have resistant starch 2 when we do cook the foods and then eat it. But then once we chill it, it usually converts into a resistant starch type 3.
Yeah, because I do remember learning at some point that when you cook your vegetables, they're a bit different, the
Mhm.
nutritional value of them. And fiber is what keeps the food stern whole, correct? So when you cook it, does that mean that the fiber content decreases?
No, not the fiber. So resistant starch is a type of fiber,
Hmm.
but it's really a separate entity than fiber that you would find naturally in food. So even though it's considered a fiber, it's we really want to talk about it as resistant starch. Even though it is a fiber, I know it's confusing, but it's
Okay.
kind of the way the government regulates our um, how we use the definition of dietary fiber in the United States.
So could you define dietary fiber for us or the different types of fiber?
Yeah, so dietary fiber is basically just any undigestible carbohydrate that confers some health benefit, and it's always plant based, basically. There are some functional fibers that have been manufactured by industry, and some of those are considered fiber as long as they meet the requirements of the government, as well as they have enough scientific research showing that it does impact some type of health outcome. So it can be classified as fiber. So we in the United States classify fiber as insoluble or soluble. So insoluble meaning it doesn't degrade in warm water, so it stays intact. Whereas soluble is going to break down when we add warm water. However, even though that's on our nutrition facts panel, that doesn't mean that that's how it actually acts in our body. So, what we really care about as clinicians and scientists is the physiological outcomes of these fibers. So, we care about fermentability, whether or not the fiber can be fermented by our gut microbes, and then the other one we care about is viscosity. Is it able to form a gel and provide some kind of a bulking agent in our digestive tract? And those are 2 completely different physiological mechanisms. And so what we see is what some soluble fibers are going to be fermentable and some insoluble fibers like resistant starch are going to be fermentable. Some soluble fibers will be viscous, whereas some insoluble will not will be viscous as well. So you can't really say, oh, all insoluble fibers are going to be fermentable or or viscous, because that's just not the case.
So, what does that actually mean for our digestive system, though?
So when we talk about certain types of viscous or bulking type of fibers, like cellulose is found in some of our over-the-counter products, and it basically just bulks the stool. So it allows for ease of defecation, so you can have less constipation. Psyllium fiber is one that is sort of a bulking, but also forms a gel in the GI tract. And so, in that gel, it can trap certain nutrients like sugar, lipids, proteins, and remove them, and even cholesterol, and remove them from the body in the feces. So, and that also helps with the movement of the digestive tract, so helps with constipation again. So those bulking and gel forming fibers actually pull water in to the GI tract, and that's how you get the different mechanisms associated with viscous and gel forming types of fiber. Whereas insoluble is going to act at the gut microbe level. And as I described earlier, the insoluble fibers will be fermentable. Not all of them are fermented, but those that are fermented will feed off of that fiber and then produce the metabolites, especially short chain fatty acids, that will allow for other health outcomes and benefits.
So, fiber's relationship to the gut microbiome, is it technically the food for our gut microbiome?
It is, exactly.
Okay. I think I remember learning that. But if fiber is the food, is our gut microbiome choosy about the type of fiber that it's
Yes, that right. So that's where it comes into, if the fiber is fermentable, then the gut microbes will feed off of it. But what we find too, some of the fermentable fibers are different in regards to how quickly the gut microbes break them down or feed them, or consume them for food, right? And they produce different metabolites, so it really is a very complex system. And you may have one gut microbe that feeds off of one type of fiber, and then another microbe likes to eat the product of whatever the initial bacteria formed. So it's very complex and dynamic. And so overall, though, when we talk about prebiotics, it confers benefit to the host, and it increases the viability and the amount of beneficial bacteria.
so it increases the amount of these bacteria, which would be in our microbiome that would eat off of these certain fibers.
Right.
So that's how these prebiotics are helping us with digestion issues.
Right.
Okay. So could you describe the difference between a prebiotic and a probiotic?
Okay. So probiotics are the actual bacteria, the live cultures that you would need to consume, but it must be in high enough amounts, in colony forming units, I believe. So, and typically, if it's called a probiotic, then it must meet the requirements, because those bacteria must survive the entire GI tract. Mind you, the pH of our stomach is around 2 or 3. So it's very, very acidic. So these bacteria must stay alive throughout the entire GI tract. And that's why they're in such high concentrations to be considered a probiotic, so they can reach the colon, the large intestine, where they can actually live.
Wow, I never knew that. So would you recommend someone should take both prebiotics and probiotics, or do you think one is greater than the other?
I would actually recommend a higher fiber diet first. And then, if we don't see beneficial changes with a high fiber diet, then I would probably recommend a both probiotic and prebiotic at the same time, because I don't think one is better than the other. You have to have the food for the beneficial bacteria to thrive. And if that food isn't there, then you're not going to get a benefit. So if somebody's on a low fiber diet, but then they start eating and ingesting a probiotic supplement or even through yogurt or dairy product or some other means, then it may not have a beneficial effect because the food is not there.
Hmm.
But they also can feed off of other things like other carbohydrates and proteins and polyphenols. So it gets very, very complex.
So there's a lot of social media. How do you describe this people? Workout fanatics. Yes.
Influencers.
So the influencers that are doing like super intense workouts, bodybuilders, I've seen them add like fiber powder supplements into their shakes. What do you think about that?
I have no idea. I mean, I think it's always great to get fiber in your diet. I mean, we need to get the recommendation is, I believe, 24 grams for women and 38 grams for men per day. We need higher amounts to get even more benefits. But as far as adding it to a supplement, other than trying to get fiber in their diet, potentially, unless their supplement has a probiotic and maybe they're adding the fiber as a prebiotic.
So wow, that's that's interesting. I never thought about that because I've seen a lot of people buy fibers lately and add them to their
Mhm.
smoothies. And I was wondering
Mhm.
if that's digested the same way as if you were to just eat a fruit or something. So speaking of proteins are a huge topic in the health industry right now. What are your thoughts on how protein impacts our microbiome?
We do know that certain sources of protein, those primarily coming from red meat and processed meats, are going to be more detrimental to the gut microbiome than some of our proteins that are plant based, like peas, beans, legumes, even soy products, things like that. So, we do know that there is something called lipopolysaccharide, LPS, and this is a product of protein digestion in our large intestine by the microbes. And this LPS is not good because it tends to break down the lining of our large intestine. And when we break that lining down, it's like a mucus lining. Think about mucus in your nose. So it just is a protective lining. But when that protection is gone, then it allows some of the pathogenic bacteria, other viruses, other harmful chemicals to get into our bloodstream and can be very problematic and cause inflammation and other issues. So, people who have a very high red meat, it's in particular choline is the nutrient that's found in a lot of red meat products. It's even in eggs too. But what I've seen the literature on is the processed meat, red meat, things like that, that can be more detrimental to our gut microbes.
So people who are on a very heavy red meat diet, would taking a prebiotic or probiotic benefit them in that case?
It could potentially.
But it wouldn't take away the side effects of eating a heavy red meat diet and digesting those
Exactly.
proteins.
Because they're also going to be devoid of all the great nutrients and fruits, vegetables, whole grains, because if they're eating high red meat or high protein diet that's heavy in meat, then they're probably displacing other healthier nutrients like healthy fats, healthy carbohydrates. So we just want to make sure the balanced diet, well rounded. Because people who eat just a red meat diet and you
Mhm.
see this guy who's just
Yeah.
gnawing on like raw red meat and it's disgusting. Uh, and you can't help but think unless he's taking a ton of supplements, which that isn't good because he's replacing all those valuable phytochemicals and really good things that are in fruits, vegetables, whole grains.
I personally do not eat red meat. But I've always wondered why red meat seems to be it goes up and down, it seems, in the health field. But why would you say what you would say like white meat? What are the differences in the nutrition between the red meat and the white meats that we see?
Well, white meat is going to be a lot more leaner in regards to saturated fat. So, if you're thinking about overall health, inflammation, and wanting to reduce your risk of cardiovascular disease, you definitely want to replace those saturated fats with the unsaturated fat. So, if you look at turkey meat, which is a white meat, it other than the skin, you don't really get a lot of what's called marbling or that hard fat. You don't really see that in the turkey meat. But if you look at a steak, look at the white outside, the white fat, it's hard at room temperature. Well, that's all saturated fat. So if that's consumed, then that is definitely going to increase risk for cardiovascular disease.
What about fish?
Oh, fish is amazing. So, fish is a really great protein source. Not only is it high in protein, but if you eat the fatty fish like salmon and mackerel and tuna, you're going to get those omega 3 fats. And we all hear about omega 3s.
Yeah.
And so these are naturally found in these fatty fish. We don't get a lot of omega 3s in other foods. We do in some of our nuts and seeds, chia seeds, for example, but especially that the longer chain fats that are important for cognition and brain health. Those are found in our fatty fish.
How would you define metabolic health?
I define metabolic health as someone who has appropriate lab values that are within range. And the lab values that I'm talking about, and not just lab values, I'm going to add some other things in a second, but let's start with we want our blood sugar to be in check. We want the fasting blood sugar to be less than 100 milligrams per deciliter. We don't want it to peak really high after we eat a meal. So we want our blood sugar fluctuations to be kind of like a wave, a small wave, not a tidal wave where we're getting those huge peaks and
Yeah.
valleys. So controlling blood sugar is number one. Controlling cholesterol is number two. So we really want low LDL cholesterol, lipoprotein, um, low density lipoproteins to be low. And then we want our HDL, high density lipoproteins, to be high. And so when those become dysregulated, then we tend to have a little bit of metabolic dysfunction. Some of the other parameters we would look at would be blood pressure. We want that to be in check. We want our body weight to be in check, and not just body weight or BMI, but we want more lean tissue compared to fat tissue. And talking about fat tissue, we want to try and steer clear of that abdominal fat, that visceral fat that can also lead to poor metabolic health.
Yeah, I've always said that to my friends trying to lose weight that you should focus more on the body fat percentage than the actual weight on the scale because that's what's really determining the health factors. But belly fat tends to be the more difficult fat to lose. So, in terms of our microbiome and these probiotics that we're using to feed off of it, what would you say would be the most beneficial for us dietary wise to I don't want to say 100% get rid of that belly fat as a no, but to aid the lowering of that belly fat.
I would start with getting probiotics and prebiotics through the food. And you can also get some of these benefits through fermentable foods. So, like your kefir or kefir, I'm not sure how exactly you say it, but
Kefir?
kefir,
Yeah,
yes,
kefir.
yes,
Yeah.
that's it. So, kefir, that is a great way to get probiotics, and now they're adding prebiotics to those formulas, at least one company that I know of. You can also hit like sauerkraut and kimchi. Some of those things are really good as well. So I would recommend higher protein, cutting out those extra sugars as well, because those are not going to be satiating at all. And then getting those healthy fats from olive oil, healthy fish, nuts and seeds, things like that.
Is there a specific type of olive oil that you would say would be better for the microbiome?
I would recommend extra virgin olive oil. And there's a couple of reasons. It tends to have a higher polyphenol content, which our gut microbes love. They also can feed off of the polyphenols. And another reason is it actually has a pretty high um, melting temperature, or not melting temperature, heating temperature. That's not the right term. Basically, you can heat it at a high temperature and it won't become rancid. So you can usually, well, not too high of a temperature, but at a medium type of temperature, enough to kind of cook some type of food like a vegetable or even some chicken or something like that.
Mm-hmm.
And you can still retain all of those bioactive properties. If you heat it too high, then you're going to make that extra virgin olive oil become rancid. But EVOOs tends to be more sustainable at higher temperatures and doesn't break down compared to the other types of olive oils or other just normal oils like canola oil.
Okay, we're going to stop off here for this episode because we don't want to become too bloated with information. Didn't we just learn that too much of anything isn't great for us? So, what were the key takeaways from this episode? Fiber-rich foods like beans, bananas, and veggies, and cold potatoes are really gut-enriching foods. Another thing we learned is that maybe choosing more of a fish or plant-based protein will be easier for your stomach to digest than if you're eating a lot of red meat, because you would need more supplements to help your little tiny citizens in you break down that meat for you to digest. Adding some more fermented foods like sauerkraut, some kefir, yogurt will also help ease the digestive system. And remember, fiber isn't about going to the bathroom. It's also feeding our second brain. So it helps balance our whole body, our whole system. And guess what? This is not going to be the end of our episodes with Dr. Mindy Patterson. Next week will be the second part of the episode with her, where she's going to go a little bit more in depth on her research on resistant starch, as well as talking about her company Renutrin, where she's making probiotics and prebiotics to help with leveling your blood sugar, as well as helping with aiding digestion. So tune in for next week's episode. Don't forget to like, share, and subscribe with everyone you know. And follow on Instagram for simple, short science clips. Until next time.